In this video, we look at phasors. Phasor represents the magnitude and phase of a sinusoid. This sinusoid is Vm cosine omega t plus phi. So this is phasor. Notation is big V represent by the magnitude of sinusoid and the phase. So Vm, the angle at phi. And this is at a phasor domain. Phasor domain means complex domain, also referred as frequency domain. If we draw this phasor, this is the real part, this is the imaginary part. This is phasor V, the length, the magnitude is Vm, the angle is phi. So remember, phasor is in complex domain. This is the complex number now. And this waveform is sinusoid, is a function of time, is a time domain. And these two signals here, if we look at this is a signal in time domain, then this may be a signal in frequency domain or a phasor domain. They are not equal. That's why you can see double arrow here. They corresponding to each other. They represent the same signal. They represent the same thing, but they cannot be equal because this is a function of time. You can see here, this is function of time. But this phasor involved with complex number. So it's in complex domain and also called frequency domain because it's related with omega. Omega, that's angular frequency. If we look at this graph here, so this is real part, this is imaginary part. So this graph you rotate counterclockwise here. So this is real part, the imaginary part. This is a Vm, and this is a V. Vm, the angle still phi. With time going here, this phasor rotate at omega. So this is a one-to-one expression of time domain and phasor domain. To understand phasor better, we can think about our hands. Our hands has two sides, the front side and the back side. We can refer the front side of our hand as time domain, and then the back of our hands as phasor domain. Although they're not the same, the front side of our hands and the back of the hand, they are not the same, but they all describe our hands. So they describe the same thing, time domain and phasor domain. It's important to remember phase represents the magnitude and phase of sinusoid of Vm cosine omega t plus phi. In other words, time domain signal is Vm cosine omega t plus phi. Phasor domain will be V, the magnitude of Vm at the angle of phi. Now let's look at different format of sinusoid. What is a phasor of Vm sine omega t plus phi? In this case, we need to convert the format of sine into the cosine. We need to use the trig identity now. We want to express sine into cosine. We're going to use this formula. Remember, all of these formulas, we work from the right-hand side to the left-hand side. So in this case, sine omega t equals cosine omega t minus 90 degrees. Remember, omega t here should be alpha. That really is sine alpha equals to cosine alpha minus 90 degrees. So therefore, sine omega t plus phi, that's this, equals to cosine omega t plus phi minus 90 degrees. So the whole thing, the whole term is the phase now. What's the phasor? That will be magnitude Vm, the angle, the phase will be phi minus 90 degrees. That's this term. So this is a phasor of sine omega t plus phi. These are the voltage surge What about the current source? I am cosine omega t plus theta. The phasor will be I am, angle is theta, and let's use different color. I am sine omega t plus theta. The phasor will be I am, that's the magnitude. The phase will be theta minus 90 degrees. Yeah. To carry on the operations in the phasor domain, meaning additions, multiplications, divisions, we want to know Euler's formula or Euler's identity. E to the power j phi equals cosine phi plus j sine phi. E to the power minus j phi equals cosine minus j sine phi. It's very handy to know if phi equals 90 degree, special case, e to the power j 90 degree equals cosine 90 degree plus j sine 90 degree. This equals to j because cosine 90 degrees that's 0 and sine 90 degrees that's 1. And e to the power minus j 90 degrees that equals to minus j. So it's very handy to know this. If not, we organize them into a formula sheet. So in this case here, the phasor, this is a polar form, can be represented by exponential form. So Vm e to the power j phi. This phasor Vm at the angle phi minus 90 degree equals Vm e to the power j phi minus 90 degree. And then we can break this power up, that equals e to the power j phi, and multiply e to the power minus j 90 degree, and that equals to minus j Vm e to the power of j phi. And this portion is the phasor of V. If we want to write this is like a phasor of V, and this equals to minus j of phasor V. This V is the phasor of Vm cosine omega t plus phi here.